Alright, great. Welcome to part 3 of this lecture. Now, most of part 2 was about in-situ temperature observations, where the thermometer that was doing the measurements of the temperature of the air was actually touching the air it was measuring. That's going to be very much in contrast to remote sensing observations, which are going to be taken by some kind of instrument that is not actually touching what it's measuring. This is actually a strategy in lots of different scientific disciplines, and there's lots of ways we use remote sensing in meteorology. In the sense of climate, for climate purposes, this is going to be done by satellites. Now, to understand what the satellites are doing, you need to know a little bit about radiation. Now, we're going to learn a lot about radiation in the third module of the course, but if I just sort of look at this sort of diagram here that's showing, here's radiation coming down from the sun to the surface of the Earth, and here's radiation being reflected by the surface of the Earth, and all this kind of good stuff here. What you need to know, for the purposes of understanding remote sensing of temperature, is to understand that the surface of the Earth emits a type of radiation. We'll learn more about why and how much and what type and all that kind of stuff next module. But the surface of the Earth is emitting a type of radiation. And the amount that it is emitting depends on the temperature. Now, this can be literally as in the temperature of the surface of the Earth itself, or this can be, as your book talks about, the fact that it could be the air in the lowest kilometer or the lowest 2 kilometers or something like that. Depends on exactly what wavelength of radiation and stuff like that. We're not going to get bogged down in that. But suffice it to say, there are ways then to measure the amount of radiation that the surface of the Earth is giving off. And as long as that's a type of radiation that can make it through the atmosphere, past all the clouds and all the dust and all that stuff that's in the air, and make it out into space, well, a passing satellite can measure that radiation. Satellites have instruments on board like cameras. They also have instruments on board that measure other things like radiation. And from that, they can do the math and figure out what was the temperature of the surface that sent that much radiation up. Okay, it's called Stefan-Boltzmann law, but we'll learn that in the third module. So satellites can be figuring out what the temperature of the surface, or again, if it's a different type of radiation, the temperature of the air near the surface or whatever, based on the amount of radiation that makes it up to the satellite. This is pretty slick stuff, and we do this all the time, and it makes for really cool stuff. Like, this is a particular result from one day of some particular instrument on board a satellite that was specifically looking at temperature of water. So we only are seeing the ocean temperatures here, but we can do the same thing with surface temperatures and so on, and other ways too. And you can see that this satellite looks down and it can see warmer water and cooler water and so on, based on the amount of radiation that is reaching the satellite from that place on the surface of the Earth. And I mean, we can zoom in and we can see that we can see all kinds of details in the ocean circulations and so on using this data. You can see the warm Gulf Stream moving up the east coast of the United States, for example. Or if you look off the west coast of South America down into the Pacific, see how there's like 2 little tons of cold water coming out. One's kind of off Mexico and one's farther down in South America. One is called a Tehuantepec and one is called a Papagayo. These are 2 kinds of storms that cool the water off the coast of South America. I'm sorry, Central America. That just caught my eye when I was looking at this just right now. You can see we can get some pretty good observations of temperature from remote sensing platforms like satellites in space. That doesn't mean that remote sensing observations don't or can't have inhomogeneities too. It's just that, we have to know to watch for them as well. Now, it's not like a city's going to get built up around your satellite or something like that, but for example, the orbit of the satellite can drift with respect to time. The time of day that the satellite passes over your location. Most meteorological and oceanographic satellites are in what we call sun-synchronous orbits. They pass over a location at a particular time of day. Maybe at 10:30 they pass over Omaha. Okay, if they pass over Omaha exactly every day at 10:30, then they can see, okay, this day I saw this much radiation coming up from the surface of the Earth over Omaha. The next day I saw this much radiation coming up from the surface of the Earth over Omaha, etc. But due to orbital drift, that time will change. Over the lifetime of the satellite, the drift might be, I don't know, on the order of minutes to hours. Well, if you are measuring that observation over that location at a different time of day than you used to, that could result in completely inhomogeneity in the surface temperature data, right? The temperature isn't really getting warmer, you're just measuring it later in the morning than you were before. Satellite instruments can get out of calibration too. It isn't like we send astronauts up there to go and test the calibration of the instruments on board the satellite. this all has to be corrected from the surface. Usually there are ways that we can get the calibration of information for the satellite, like they turn the cameras once a day to go look at some known source, like the moon or a particular star, and they figure out how much radiation is coming from that known source, and they can use that to calibrate the satellite. But I mean, if for some reason like the satellite can't be calibrated anymore or whatever, well, we need to be able to fix that. Now again, as long as scientists can figure out that detect that there is a problem, there's always statistical ways to fix this, and finding such problems and documenting them and fixing them is a big part of what goes on at these federal research labs and so on. They make sure that the data are very consistent and homogeneous and so on. Now, before we move on to part 4 of the lecture, I want to talk a little bit about these remote sensing observations and so on. Now, let's just ask 2 quick questions here. Surface temperature observations of, surface temperature determines the amount of radiation blank that hits the surface, absorbed by the surface, reflected by the surface, or emitted by the surface. Which of these is the right answer as to what determines the amount of surface surface temperature determines the amount of radiation? Which of these is the right answer? Pick your choice from the 4 below here, and I'll give you feedback before we move on to question 7.